Hello, welcome to the video notes for lesson 12-1. This is the first lesson for topic 12, the Pythagorean theorem. This might be the first time you've ever heard this word. However, I bet if you say this to your parents, many of them will at least have heard of this if they don't remember exactly what it is. The Pythagorean theorem, very popular, well-known, powerful theorem throughout mathematics. So let's go ahead and get started. The lesson targets are: I can find the missing side of a right triangle using the Pythagorean theorem. I can determine if a triangle is a right triangle using the Pythagorean theorem. And I can use the Pythagorean theorem to solve real-world problems. We're always striving to solve real-world problems no matter what we do. Okay. In a right triangle, notice it says right triangle. That's the key to the Pythagorean theorem, is we're dealing with right triangles. The side opposite the right angle is this is a funny looking word, hypotenuse. I'll say it again, hypotenuse. It is not hypotenuse, it's hypotenuse. It is the longest side. Each of the sides forming the right angle is a leg. Alright, so let's just point something out here. So the hypotenuse is always the longest side, and usually it's pretty obvious and easy to tell. If not, if you can't tell which one's the longest, it should be the one opposite the right angle, and that makes the other two shorter sides the right of the leg. The Pythagorean theorem describes the relationship of the lengths of the sides of the right triangle. So now we have what the Pythagorean theorem is. In any right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. Some of you might be saying, well, what does all that mean? If we label the legs A and B, and we label the hypotenuse C, A squared, so A times A, times plus B squared, B times B, should equal whatever C is squared. So this is the Pythagorean theorem. Such a powerful, powerful equation, formula, if you will. Alright, and we have an example of this below. So it's kind of a weird looking picture. You have the right triangle on the inside here. The side length for this, for one of the legs, is 3. 1, 2, 3 boxes. The other leg is 4. Now, if I do 3 squared, I get 9. If I do 4 squared, I get 16. So I have 16 cubes or squares in here, 9 in here. Now, 9 plus 16 is 25. So, what do I have over here? Well, the side length is 5, and 5 squared is 25. So that's this all-powerful theorem or formula. Okay, let's do some practice problems. It's the best way to see it. So go ahead and turn or look at page 2. Determine the missing side. So everybody write this down at the top of your paper. A squared plus B squared equals C squared. Alright, so here's our right angle. So across from it is the hypotenuse. And in the Pythagorean theorem, A and B don't matter. We can switch those around. But C has to be the longest side, or the hypotenuse. We're trying to find the hypotenuse. A will make the side that's 8, and B will make B the side that's 6. So we're going to do A squared plus B squared equals C squared. A will plug in 8, B will plug in 6, and C we still don't know. Now we have to square them. 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. Now, that's the square of C. We don't want that. We want the square root of it. So, what's the square root of 100? 10. 10 equals C. So, what is the side length up here? It is 10. Alright. Pretty simple, right? Okay. Now, this time, we have our C value, but we don't have this over here. I'll call this A. Doesn't matter if you want to call it B. B this time we don't know. So A squared plus B squared equals C squared. Plug in 5 for A. B we don't know, so we'll leave it a variable. C we know is 13. 25 plus B squared equals, you should all know, 13 squared, 169. Now, it's an equation, so we're going to solve it by subtracting 25 from both sides. And when you do, B squared equals 144. Now, that is not the final answer. We have to remember to take the square root. And we get B equals square root of 144 is 12. Now, when we plug it into our final answer, make sure you have the label of feet. And it works out beautifully. Now, it's not always going to be a perfect square. If we look at the examples below, they are not. So, here is the side opposite the hypotenuse. So this is my C, and I don't know it. So I'll make A this one, B this one. So, A squared plus B squared equals C squared. A is 2. B is 2. C we don't know, so we'll leave it a variable. So 4 plus 4 equals C squared. 4 plus 4 is 8. Now that is not the final answer. Final answer is the square root of that. And it's not a perfect square. So C equals, we can leave it the square root of 8 as an answer sometimes. Sometimes, and I'll talk to you in class about what another name for the square root is, but it can also be called a radical symbol. Or you might be told to round it, so we'll round it to the nearest tenth. I'm going to use an approximation sign, so it's almost 2.8. And there's no label for this, so we'll just leave it the number. Alright, one more time. Again, our hypotenuse is across in the right angle, so C is this. A, we don't know. I just switched it around. B, we know is 7. A squared plus B squared equals C squared. This time we don't know A, we know B, and we know C. Hopefully you remember your perfect squares, so you don't need a calculator for this, although don't be afraid to use it. Subtract 49 from both sides. A squared equals 176. That is not a perfect square. By the way, we got to take the square root to find our final answer. And, you know what? Sometimes you can leave your final answer in this form. So A could equal the square root of 176. Or it is about, and then if I plug that into my calculator and round it to the nearest tenth, 13.3 inches. So that is the Pythagorean theorem. There's a couple more examples on the next page, and that's part of your homework, so make sure you try page 3 on your own. The answers are at the bottom. Don't look at them. Use them after you try them. If you had any trouble with this video, go back and rewatch it or come and see me for help. Good luck, and we'll see you in math.